Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we will embark our journey from basic to advanced physics. This is lecture number 4 on 1D motion of velocity and acceleration. In the last lecture, we have learned about distance, displacement, average velocity, and average speed. Then before going further on velocity and acceleration, we have gone through the lecture series on calculus, where we learn how to perform integration and derivative on various functions. In this lecture, we are going to learn about instantaneous velocity, commonly called as velocity, average acceleration, instantaneous acceleration, commonly called as acceleration. So let's get started. You remember in the previous video that we calculated average velocity and speed by considering the displacement and distance per change in time. But that calculation was for the whole trip, unlike instantaneous velocity. For example, for getting an intuition on what velocity is, let us take an example of car or bike, whichever you ride or you are not old enough to drive, you might have accompanied with someone on a drive. So, while driving during the journey, you might be observing the speed on speedometer. There is a pointer which points to a speed of a vehicle, so in any random time during the journey, you might see the pointer pointing at a particular speed. So, at any particular time, you observe a speed is instantaneous velocity, the velocity found at an instant. How it is different from average velocity, you say? Average velocity is the velocity calculated for whole journey. Unlike here, the instantaneous velocity is the velocity at a particular instant or second. Guys, further discussion will proceed by using the concept of calculus. If you are familiar with calculus, then you can go further. Otherwise, you can watch my previous calculus series of lecture number 3 divided into 4 parts. There I have created 2 theory and 2 methods and example videos. So from the last lecture, you know that average velocity is delta x divided by delta t. Then how do we find out the instantaneous velocity at an instant from this formula? If you have watched my derivative lecture, you might remember that for a slope of delta y upon delta x, when limit of delta x tends to 0, then whole equation will transform as dy by dx. In our case, we have average velocity as delta x upon delta t. And when delta t approaches to 0, then we get dx by dt. The velocity is one dimensional along x direction. So this is instantaneous velocity. For now on, we just call it as velocity. And just like displacement at average velocity, it is a vector quantity. That means velocity will have both magnitude and direction. And the magnitude of velocity is the speed of particular object. This is mathematical form of velocity. By using this concept, you will be able to find the velocity of the object at any particular time for a given real valued function. Because of the time constraint, I am dividing this lecture into 2 parts. The first lecture will consist of only velocity. The second lecture will consist of acceleration. You can support me on Facebook and Instagram by following @PhiShastra. Link in the description below. Please subscribe my channel. Your gracious subscribe will encourage me to work harder and more better. Till then, stay tuned.